Morning, CSEC students. Welcome back to Kemet Maasai Academy and continuing our series of live classes. This morning, we're going to be looking at matrices. It's an introductory class this morning. So we're just going to do some very basic matrices this morning. So just very basic. What is a matrix and how we can combine matrices. Before I do that, I'm going to play for you the schedule of classes we do every week. 6 lab CSEC classes every week and 5 PEP classes. And so here's the I want you to write down these dates, write times, and so you don't miss any of the classes. So here's hello CSEC math students. I know you are busy preparing for your math test and your CSEC exams coming up. I have a very important question to ask. Do you like my new hat? Thank you. No. Question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure as thousands of other students have. Now we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Most times when students get problems wrong in mathematics is as a result of one single error or one mistake, where this is absolutely true, and we're going to be on errors that students make in different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Ready? Come on. All right, students, welcome back. And let me apologize for that the schedule, the video schedule, technical difficulties there. So we're going to continue now. If you're hearing me loud and clear, just let me know, please, in the chat. Those in the chat, if you're able to hear me loud and clear, just say, I can hear you, miss. Not seen. Okay. All right. So they're saying they're hearing me. Okay, so let's go. right? So it's matrices, CSEC. And we're just going to do some simple operations here in matrices. So matrix is a way of writing values, expressing values, and we can express equations. We can use it to compare quantities. When we're using matrix, we use a row by column system. Let's say the typical matrix would be a 2 by 2 matrix. For example, the rows go across. So it's row by, the rows go across and the columns go down. And would be how many rows, how many columns, right? That's it. So when we ask for the order, this matrix here, write it. So we have 2 rows, 2, another row, and then we have 2 columns. So 2 by 2 matrix, 2 rows, 2 columns. If we had this, if we had a matrix that looks like this, the order of this matrix would be 2 by 1. 2 rows, so the 7 is in, and then this is the column. So 2 rows, 2 columns. If we had it like this, we don't use add 7, that to be a 1 by 2 matrix. 1, and this is 1 column by itself, 1 column by itself. So as a quick activity, I'm going to put, so I want you to tell me the order. Number 1 of them, just for a little practice to start with. All right, so for number, and let's say we have 2 more numbers down there, right? What is the order of that matrix? Quickly. So type in the chat for number. What is the order of the matrix? Type your answers, students. And while you're doing that, I'm going to write the other. So you're typing your answer for 1. In the meantime, put the other matrices, and you're going to type your answers, and in the meantime, so I'm writing this. So that's number 2, 3, I think we have space, we can hold 5 of them. Last one. All right, so there we go. We have 5 matrices. All right, so number 1, we have persons are saying 3 by 3 for number 1. Iman is saying 3 by 3. The 4 and -5, they are in one row by themselves. So remember, the rows horizontally and the column vertically. So the 4 and the -5, that's one. The 6 and the 3, that's one row. The 0 and the 1, that's one row. So it's three rows. In terms of the columns, the 4s are in one column. The -5, 3, and 1 are in one column. So that's 2 columns. So for number 1, it's a 3 by 2 matrix. 3 rows, 2 columns. For number 2, 0, 1, 4, that's one row. 3, -2, 5, 0, that's another. 4, 7, 1, 8 rows. So 3 rows. And the column, so looking vertically, we have 2, 3, 4, that's one column. 0, -2, 7, another column. 1, 1, that's another column. And 4, 0, 8 is another column. So for number 2, we have 3, 4 columns. Number 3, each one of those numbers is in a row by itself, and then all 3 of them together are in one column coming down. Number 3 is a 3 by 1, 3 rows, 1 column. Number 4, we have 3 rows, 2 columns. And number 5, we have 2 rows, 4 columns. So number 3 is 3 by 1. Number 4 is a 3 by 2. And number 5, 4 matrix. So let's go on now to actually some matrices. When we're in matrices, we simply look to see what corresponds to which, and they're in this order. And we just look corresponding numbers. So, for example, we have 4, 0, -6, -7, and here we have -5, 8, 11, and 2. Corresponding corners. So the 4 is in the same corner. 5. We're going to add 4, -5, and we get -1. 0 plus 8, 8. All right, so we had a glitch a while, so let me. So that's 8, is 8. Negative 7 gives a positive. And negative 7 plus 2 gives a negative 5. A couple more addition, and then we do some. Do about after this, and then we do about 4 subtraction. And that should be it, because it's pretty simple. In our next matrices class, we can do and regular multiplication of matrices. All right, so again, with corners, and we switch the other number in the matrix. So negative 7 is the same as negative 9. So it's negative plus negative 9, which is negative 16. 1 plus 0, which is 0 plus 2, which is 2, and 3 plus negative 8, which is negative 5. Let's do 2 more done, and then we go on to subtraction. And it can and fractions in it. So let's do a fraction. So let's say we have 3/4. 1, we had 0, we had a half, plus 1/3, negative 6, 5. And let's do 1 decimal, just to that you can only have whole numbers in the matrix. You have to be able to, in case you end up with fractions, decimals, it doesn't matter. It's the same principle. You add them, or if it's a subtraction, subtract them, or multiplication, or whatever it is. So let's say we have 2.5, 3, negative 1, 0, 5. We have negative 7, 8. Just to put in, I'm just putting in some random numbers. All right. So we have 3/4, we have 1/3. So just go to the side, work out 3/4 plus 1/3. You know, LCM is going to be 12. 4 into 12, 3 times, and 3 into 12, 4 times, plus 4 is 4. So this gives 13 over 12. We can put it either way. It makes sure to put your improper fractions. Put it over 12 for that one, right? Negative 1 plus 2, so that's a positive 1. Minus 6, so 0 plus negative 6. That's negative 6. A half plus 5, that's 5.5. You can write it as the 5.5. So just for variety, just to show you the different options. You can put it as 11 over 2, whichever way you want to. Decimal, so we have 2.5. So half, and we're subtracting 7. All right, so that's negative 4.5. Or you could write it as negative 4.5 plus 8. So that's negative 1 plus 5. So remember, 0.5 is a half. Negative 1 0.5 is negative 0.5. And oh, I didn't put any number. 10 plus 0, we know it's the same, 10. All right, so that's the addition of. All we have to do is see which of the matrices correspond and add those ones. The ones that are in the same corner, we add them. This is the same principle for the subtraction. Thing for the subtraction of matrices, remember your rules as they apply to subtracting negative numbers. That is very important. So maybe we should go over some of those rules first. So if you're subtracting, we have 2 minus 7. 7 than the 7. So we're taking a bigger number from a smaller number. So it's just like on the 9, that's 0. That's 2. When you're taking away on the number line, you move to the left. So from 2, we'd move 1, 2, 6, 7. It would take us to negative. So 5 places from 0, 5 places to the left of 0. So if you're starting with a smaller number and you're going to take away a bigger number, it's going to be negative. So that's negative 5. 3 minus 4. When we have a minus negative in the middle here, as adding. 3 minus negative 4 is the same as saying 3 plus. Likewise, negative 3 minus negative 4 is the same as saying negative 3. So 3 minus 4 would give 7. 3 minus negative 4 would give. So those you have to remember the subtraction of matrices. Again, also 0 minus 5. So 0 minus 5, negative 5. But 0 minus negative 5 minus negative work as a plus. So 0 minus negative 5 is the same as 0 plus 5. This would be. Bear these things in mind and you'll master matrices. Once you have this down pat, you're good to go. All right, so let's do some actual subtraction of matrices. And we're going to do 4 of them. We did 4 of the addition. It's in good standing with our subtract matrices that are of the same order. And typically at this level, you're working with 2 by 2, typically. All right. My mom in a lot of dilly-dally. So let's just put in some random numbers to make sure we have 0, we have positives, just to make sure every will cover. You know, we love to cover all our bases. You know, to make sure that we cover from every angle. When you are given any problems, no matter, you should be able to manage, because in class we practice all the possible, and I especially difficult ones, so that you know what to do, handle yourself. Let's put the answers in a different color since we are there. So what we're working with here is which number. So the -5, same corner as the 3. And remember, we have our addition operation happening here. So it's -5 minus 3. That's what we really do. -5 minus 3. So we start with a negative number, and still moving to the left because we're subtracting. As going to say it's like digits, and the answer remains negative. So that will give -8. This morning we have 0 minus 4. So 0 minus 4, and that gives a -4 minus -6. -4 minus 6. So remember, we have a minus negative. It's was a plus. Really, that is going to give a positive 2. And then we have -1. So it's minus -1. Again, we're working in the middle with a minus negative. -1 is 9. For number 2, corresponding digits, 4 minus -5. +4 minus 5. The minus negative works as a plus. Plus 5 is really what we're, and that's going to give 9. Then we have 4 minus, which everybody knows that's. We have 0. So it's just like we still have our negative because we're taking nothing. So 8 is smaller than 10. So we're going to move 8 places to 0, and it's going to leave 2 in the negative side. 8 take away 10 is negative. To try 2 more. Again, ensure that we use up some negatives, some use. That's number 3. All right. And number 4. -7.5. 4.5. 0, 6. 1, negative 5. And down here, negative 8, negative 2, 3, 12, 4, negative 1. All right. So in this column, we have a negative 7.5, and we are subtracting 6. With a negative number, and you're subtracting, moving to the left on the number line. So it's the same as adding the digits, and the answer is negative 7.5 plus 6. So that's negative 13.5. We have 4 minus 1, which everybody knows that's 3. We have 1.5 minus, so 1 minus 2. So move back 1.5 places will take us to 0, and what is a negative 0.5. We have 0 minus negative 5. So 0, negative 5. And we know that the minus negative is going to work as a plus. So it's the same as 0, which is a positive 5. Looking at the corresponding values here, we have a 0 minus 0 minus 12 is negative 12. We have a negative 2. If we start negative 2, we start at negative 2, and then we take away 4. So we're to add the 2 and the 4, and the answer remains negative. It will be negative 6. We have negative minus 0. So negative 8, 0, same negative 8. And then we have 3, negative 1. So 3 minus negative 1. The minus negative plus. So that's the same as 3 plus 1, which is 3. That's it for addition and subtraction of. So to recap, matrices that are in the same, that are of the same order. And what I mean by the order of a matrix is many rows by how many columns. The rows go horizontally, the columns go vertically. Doing here, we have been working with 2 by 2 matrices, which are what you are likely to get at the CSEC for addition and subtraction. Multiply matrices that are not of the same order. When we do matrices again, we're going to do our multiplication, which is multiplying a matrix by a term. And we're also going to look at multiplication of other matrices. Typically, a 2 by 2 matrix, another 2 by 2 matrix. That's the kind you're likely at this level. we will look at the of a matrix, which in some sense you could say that's division of matrices. You could look at it that way. We look at matrices solve simultaneous equations. So you'll find simultaneous equations, different methods of solving them. You can solve them the algebraic method, which has actually two methods, substitution and elimination. You can solve simultaneous equations the graphical method, so intersecting the graphs and reading the solutions from the graph, and then there's a matrix way of them. Those are the subtopics we'll be doing in matrices: scalar multiplication, regular multiplication, inverse of a matrix, and simultaneous equations. Excuse me a minute. All right, so that's it, students. So I'll see class and continue our lessons on matrices. hello CSEC math for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you